Alright, this video will cover section 3.5 on rational functions. So remember, rational functions are the functions where it's a fraction and the denominator is where the variable is located, or there is a variable in the denominator. Alright, and what we're going to do is we're going to look at graphing some rational functions. Before we do that, we want to look at the degree of a polynomial, because this is going to help us decide about some of the where our graph is going to go. Alright, so the largest degree or power of any term of the polynomial is known as the degree of the polynomial. So we're just looking at the largest exponent in our case. Alright, when I'm graphing rational functions, remember there's a value that the denominator can't beat, and that is 0. Alright, and in that, when the denominator is 0, then that is a place where our function is undefined. And so any place where our function is undefined is known as an asymptote. And we have vertical asymptotes and horizontal asymptotes. These are not something that are visibly seen. Alright, they're kind of like imaginary lines where our graph cannot touch or cross. Alright, and there are vertical and horizontal ones. For the test's sake, we're going to look at simply the vertical ones. Okay, I'll show you how to do the horizontal ones on a couple, but for the test's sake, I want you to be able to find the vertical asymptotes. Okay, so if I have these two rational functions, I want to find the vertical and horizontal asymptotes. For the vertical asymptote, I simply take the denominator and I set it equal to 0, and I solve for x. So at x equal 3, there is a vertical asymptote, and that means at x equal 3, the graph of this function cannot touch there. It may get really close, but it will never touch or cross this imaginary line. And I'll show you what I mean here shortly. Alright, for the horizontal asymptotes, you have two possibilities. Alright, if the numerator has a lower degree than the denominator, then the horizontal asymptote is y equals 0. So you look at the degree. If the exponent in the numerator is smaller than the one in the denominator, the horizontal asymptote is at y equals 0, which is simply the x-axis. If the numerator and denominator have the same degree, meaning they have the same exponents, then you take the two terms and simplify them, and that will be what y equals, or where the horizontal asymptote will be. So if you look at this problem here, 2x plus 1 over x minus 3, alright, the degree of the top, or the numerator, I'm going to look at the exponent on this variable here is a 1, and the exponent on this variable is a 1, so they have the same degree. So that means I'm going to use option B here, and I'm going to take 2x over x and simplify that. The x's will divide out and leave 2. So that means I have a horizontal asymptote at y equals 2. Alright, now if you'll scoot down here to the bottom, alright, on part 2, problem B, this is the same problem that we just solved. Alright, and we said there was a vertical asymptote at x equal 3. So I'm going to go draw me a line, vertical line, at x equal 3. Alright, and I'm going to make it a dashed line. Alright, because really, if you did this on a graphing calculator or some other graphing utility, you would not see the vertical asymptote, but this just helps us to make sure we are not crossing our graph across this area. Alright, that's my vertical one. My horizontal one is at y equals 2. Alright, so if I'm on the y-axis, I'm going to go to where y is 2, and that is here, and I'm going to put me a horizontal line. Alright, and if you go look at your parent functions in the back of your textbook, or in the information that I gave you earlier in the semester, alright, and look at the parent functions, and you'll see 1 over x, what the graph looks like. Alright, and it kind of looks something like this. There will be 2 parts to the graph. Alright, so since my graph can't touch x equal 3, then 3 can't be an x, because that would make my function undefined if I filled that into the denominator. Alright, so remember we found that on the last test when we were doing domain. And for a rational one, where the fraction we set the denominator and found what x could not be. And that is this vertical asymptote. X cannot be that. So what I'm going to do is pick some values to the left and right of that. So let's see, how about 2, 1, 0, and 4, 5, 6. And then I can fill those into my function and kind of get an idea of where my graph is going to go. So if I fill in a 0, I'll get negative 1/3. And if I fill in a 1, I'll get negative 3/2. And if I fill in a 2, I'll get 5. And so I'm just taking these x values and I'm filling them in for x. So 2 times 0 is 0 plus 1 is 1. 1 minus, 0 minus 3 is negative 3. So that'll be negative 1/3. And then I'm doing that same thing with 1, same thing with 2. Then I'm going to fill in a 4. So 2 times 4 is 8 plus 1 is 9. And then on the bottom, 4 minus 3 is 1. So that'll be 9/1, which is 9. And then here I'll have 2 times 5 is 10, plus 1 is 11. And then 5 minus 3 is 2, so that'll be 11/2. And then 12 plus 1 is 13. And 6 minus 3 is 3. Alright, and then I'm going to plot these points. So when x is 0, y is a negative 1/3. 1, it's 1.5. And when it is 2, let's see, I got one. It should be negative 5. 2, yeah. So 2 minus 3 is negative 1. That should be a negative 5 down here. Alright, so the bottom portion of my graph should get closer and closer and closer to my asymptotes, but never touch them. Alright, and then there's still graph in this direction. It should get closer and closer to my horizontal asymptote, but never touch it. Then if I graph the other side, 4, 5, 6, that'll be 4, 9 is somewhere up here. And then 5, 11/2 is about 5.5. It'll be right there. 6 will be about 4 1/3 or so. Alright, so when I connect the dots, alright, anytime you have a rational function, they should be on opposite sides. Alright, for test purposes, I want you to be able to simply find the vertical asymptotes. Okay, so if we come back up here to part B, and I ask you to simply find the vertical asymptote, you're going to take the denominator and set it equal to 0. So for this one, I would say 2x minus 1 equals 0, and x plus 3 equals 0. Then when I solve for x, I'll get 1/2 and negative 3. So I'll have two vertical asymptotes at x equal 1/2 and x equal negative 3. And then if I found the vertical asymptote on this one, I would simply say x equals 0, and there's nothing left to solve. So for test purposes, make sure that you're able to find the vertical asymptotes.